Hello, my name is Mohammad Rashad. The research paper topic which I am going to defend is smart surveillance through periocular biometrics. The set of activities was supervised and organized under the mentorship of Dr. Muhammad Imran Malik. In GC member, I have Dr. Faisal Shafat, Dr. Muhammad Shehzad, and Dr. Muhammad Ali Tahir. This is the agenda of the presentation going from introduction of periocular biometrics. Then I will tell the motivation and background of the underlying research. Then I will pose some research question which I formulated before to carry on the study. After research question, I will tell the literature review which I gathered corresponding to my data set and the gaps which I have identified. What problem statement I have, later what methodology I have adopted, then of course the dataset description which I have used in this research paper, and then solution statement and results. Before delve into the periocular biometrics in details, one should know what is periocular biometrics. According to IEEE definition, periocular refers to the facial region in the eye vicinity including eyelids, lashes and eyebrows. But after details and rigorous study, the periocular is not confined to these only subset of face feature. But there are other features as well, like pupil, iris, eyelids, inner corner, tear duct, sclera, cheek skin texture, and outer corner. So taking these all features as combined is collectively termed as periocular biometrics. This is the introduction, background and motivation. The intruder which is going to take an unauthorized access of someone's premises, if he or she even masked, they have to expose one region, that is vision or eyes. Taking the leverage of that exposed region, one can take those exposed feature and identify that intruder. I have divided these overall research work after taking the top view of this area. The first one, the detection scenario, and upon detection extract the features and feed those features into the model and generate latent vector and perform one hot encoding type, or to finally evaluate the classification, that is the recognition. So I have here I have calculated the IOU score for evaluation, how best is my model is detecting the eyes into the pictures or somewhere in the CCTV cameras, like that. And then I have evaluated the my results by plotting the confusion matrix, and upon that confusion matrix I have calculated the equal error rate, false acceptance rates, false rejection rate, and accuracy. These are the possible use cases where my research work could be very effective. These images are taken from recent research work where authors tried to use deep learning techniques to extract feature and classify them into their real subject name. The paper link I will provide in the description of this video. These are the possible areas where periocular biometrics can play a major role, like computer vision and pattern recognition, forensic analysis, human-computer interaction, video surveillance, criminal investigation, security and safety management system, etc. These are the research questions which I have posed before carrying the study. First, the question which I have taken is what are the oculus region of importance. There was a subjective experiment performed in MIT where pictures were provided to certain group of people. Picture was provided with the subtle variation in periocular biometrics, with eyebrows and without eyebrows, with eyes and without eyes. Later they were asked to identify or recognize the person. Interesting results were there where the people were less likely to recognize those person having no eyebrows, which means the person with eyebrows has more chances to recognize. Similarly, some more questions that I have posed: how to detect or localize the periocular region (ROI). Also, how can we split that into left or right eyes? Do we know the second eyes as well, or we just need one eye and take the symmetry like horizontal fret will also work? Does performance degradation factors like distance, illumination will affect the results? What variation factors can during my model could face while periocular biometric were taken into the account? How traditional feature extraction techniques work into the periocular biometrics like local binary patterns, Gabor filters, similar kind of feature hand picking features. What possible image augmentation technique we must have to adopt to overcome these performance degradation factors? This is the literature review section. The first paper which I have chosen corresponding to my data set is fusing iris and periocular information for cross sensor recognition. Paper was published in elsewhere. They have synthesized or captured their own data set. They evaluated a result based on equal error rate and varying the equal error rate from 25 to 34. They didn't perform. I have performed the critical analysis on this paper. They didn't perform the detection. Claim that only identification is happening only based on periocular was less certain. Simple feature matching X square distance was used. The paper was published in 2014. The second paper which I have taken as a benchmark corresponding to my second data set was accurate periocular recognition under less constrained environment using semantic convolutional neural network. The paper was published in IEEE Fox Face Oculus Challenge Series. Data was considered, which I have also considered in my research. Feature evaluation, SCNN, and convolutional neural networks evaluation criteria. Evaluation criteria which they have used is equal error rate and 96% accuracy they got upon correct recognition, and equal error rate was varying from 10 to 11. I have performed also the critical analysis of this paper. Detection of ROI, ground truth detection of ROI was not reported. Ground truth for ROI was not available. Only 136 subjects were considered. NIR, near infrared images, and the subject was very cooperative, and means they have taken the images from very near distance and does not put those images to the surveillance. So objectionable partitioning, 80 subject training, and rest the subject were taken into the test. The paper was published in 2017. Similarly, the other paper in this on the same data set where the same problem was that they didn't reported the detection of ROI ground truth. The paper was published in 2013, and simple handcrafted feature histogram of gradient, single invariant feature transformation, and PDM was used. I think PDM stands for probabilistic deterministic map or machine, and they got the equal error rate of about 18.8. Similarly, the paper 4 where also the critical analysis were the same like previous ones, and the fifth paper which I have considered as a benchmark and compared the accuracies and equal error rate. The paper was published in 2013 and 2014. The literature gap which I have shown in this contingency table, or we can say the cross table, we can see the major flaw in this slide where they didn't reported their detection results. They have fed the images as a raw pixel without taking the certain region to identify. Simply handcrafted features were used except the P2 paper where therefore we can where they have used the automatic feature selection, that convolutional neural networks. At the time, simple handcrafted, therefore we can say that they have considered one periocular biometric at a time and performed recognition upon them, rather taking all the feature like pupil, distance between the eyes, or they have considered one feature at a time. This was the problem statement to create a model for suspect intruder identification using the periocular biometry, which is efficient, accurate, and reliable, and of course reliable using the deep learning techniques. Now I am switching towards my working framework of machine learning, how I have proceeded my work. I have mapped my all planned work backlog into an industrial working framework and how I should process my set of activities. Some of the activities were in the scope of this research paper, or we can say the thesis, while some activities were left for future inference if we plan to lead these results to some product and try to fit the business model into it. This is the first step that I have performed to explore dataset corresponding to periocular biometrics. I have narrow down these two major sets from a latest survey. These are the characteristics of the data, where the first data is cross sensor iris periocular, where they have 50 subjects. Total number of data samples they have, the total images are 2004. The size, they have no fixed size of dimension of images, because the images were captured from different volunteers having different mobiles and different front camera and resolution and rear camera images. Ground truth was available, but the ground truth for region of interest were not available. Illumination was present, cross spectrum was present, because the images were captured from different sensors, therefore different mobiles, therefore they have different sensors. So a kind of performance degradation are also coming from different sensors illumination factors. The distance was the images were captured from different distances. Expression was not present. Lighting was present. Occlusion was present, like glasses wearing without glasses and glasses and with glasses. Pose was also present in the images. Similarly, the Fox image, where 437 subjects were considered, data number 79581. The size of each image resolution was fixed, 750 cross 600. Ground truths were not available for ROI, and near infrared images were and the colored images were also present. Cross spectrum was not present because all the images were taken from the same environment, same camera. Distance was present, and expression was present, lighting was present, occlusion was present, and pose was also present. These are the sample images from a cross sensor iris periocular. This is the link of is given where I have downloaded this data after signing the NDA non-disclosure agreement with them. So below these number have some below these numbers have some semantic meaning, and trying to associate these meaning with the image, that how a specific image was captured. Here A stand for that this image was captured with Sony Ericsson. B stand for that this image was captured with Apple. C stand for that it is captured from TSL. D stand for that the image was captured with Huawei mobiles. This which version of operating system was also installed, which operating system was installed, image was captured from both front and rear camera, therefore the cross spectrum term was introduced. 0 and 1 binary shows that the image was on, or that the flash was on or off while capturing the image. And F stand for that the image was captured from front camera, and R stand for that image was captured from rear camera of the mobile. This is the description of the semantic meaning that I have written, I have formulated, I have populated a table with those features. Now how Fox has acquired the data, what sensor setup they have adopted. This is the motivation that to develop a multi-model algorithm that to train the model on single image, and the model should be capable enough that if the same subject come with just iris or in a video, it should be able to recognize. These were the sensor setup where two cameras of high definition and NIR were set up in front of a walkthrough gate, and the camera were able to capture images while moving the subject. Take 3 images while walking through these through this gate. If these images are above this certain aesthetic threshold, those images keep those images, otherwise discard them. These are some challenges they consider while acquiring the dataset. Take these video sequence of the data as a test case, and try to match those images that capture and calculate the similarity score. Similarly, these are the multiple biometric challenge. Take the full frontal images and iris and try to match the query video and try to calculate the similarity score. The dataset was acquired after signing the non-disclosure agreement with National Institute of Science and Technology, NIST. They exposed the data through FTP server after a file transfer protocol server. After acquiring the dataset and understanding of dataset signatures, image augmentation were performed. This was the task for image augmentation. ROI were extracted from the whole face still images and then applied the data pre-processing technique like random scaling and cropping, scaling, color, contrast, horizontal flip, red blur, gray scale, random noise in the image. After applying these image augmentation, original images were there. After augmentation, the data set was augmented to these number of images. Catching the above challenge, I used the transfer learning technique. Which pre-trained model should I have to adopt? Decision was taken by referring the documentation of Keras TensorFlow, where they reported the results by taking the ImageNet dataset as a benchmark. I have set two parameters to evaluate the model. First the size of the model, and then the top 1 and 5 accuracies, and finally I have selected the Mobilenets. Being a lightweight, it would definitely be helpful in real-time detection and identification of the subject. Rest are very heavy models, therefore I cannot use in the real-time detection or surveillance, because my research paper is corresponding to the surveillance activity, so that's why I have chosen this small size model. Once the ROI get extracted through cropping, it was fed to data augmentation like color jittering, scaling. Some semantic labels were assigned using the any bounding box tool. This process generated some XML having X and Y coordinates. Because detection is a regression problem, right? That's why these coordinates behave like a ground truth for learning model. These coordinates were then converted to CSV and make a mapping upon the training set. Through TF record, these cropped portion were extracted and converted into an array of binaries for utilizing the memory efficiently. The data was split in training and testing, 80% and 20%. Hyperparameter were tuned and using hill climbing search to tune the parameters, and correctly detected the region of interest with IOU score of bounding box. And evaluated these upon the false acceptance and false rejection and accuracy. This was the proposed methodology which I have adopted. So I have evaluated my detection results upon using the IOU score, where I got IOU score of 95% and upon setting the threshold of 60%. Similarly for Fox, where I have got the 60%, 92% on Fox, where I have reported here, where I got the detection result of 92% upon Fox dataset. This is the block diagram of top level architecture of my proposed methodology, where taking the raw pixel images, detected the ROI, extracted those ROIs and necessary augmentation. It was fed to pre-trained model, and evaluation of results were formulated by plotting the confusion matrix. All evaluation matrices were based upon matrices like false acceptance rate, false rejection rate, and equal error rate, were based on that confusion matrix that was plotted behind previously. These are my results. First, how correctly I was able to detect that ROI is given here. I used to evaluate the IOU score. This was the CSIP result. Similarly, the results were calculated for Fox. This was the confusion matrix of 50 cross 50, having 50 subjects. True labels are on y-axis and predicted label are on x-axis. Each subject had support of 4 images. You can see here the 4 image. Each subject had support of 4 images. The heat matrix support in heat map is given in the scale depicted on this right side. The diagonal showing the correctly classified image, the upper and lower diagonal showing the misclassification or false positive, true negative, or the false negative, negatives. Once the confusion matrix is plotted, I was able to determine true positive rate and false positive rates. Excuse me. And equal error rate based on these formulas. TPR is also called the recall, or also termed it as sensitivity. Similarly to negative rate, which is also called the precision or specificity. So this sensitivity, basically true positive rate hit, also called the hit rate or recall of a classifier, represents the correctly classified sample to the total number of positive samples, and it is according to this equation. Whereas specificity or true negative rate or inverse, we also call the inverse recall, or is expressed as ratio of the correctly classified negative examples to the total number of negative samples. Specificity represents the portion of the negative samples that were correctly classified, and sensitivity is the portion of the positive samples that were correctly classified. To have the same wavelength as the NIST reported the results, the dataset was first partitioned in, and this was the equal error rate that I got after adopting my methodology. The equal error rate I got 0.48 using these softmax, and learning aid was kept 0.005. Adam was used as the no dropout was used. Adam the parameter tuning, and softmax was also used. The categorical loss was 0.0030. Validation loss, I have reported categorical accuracy I was captured upon 99.98. One hot encoding. Average accuracy was 99.51, and rank 2 accuracy and rank 2 was 101. That the rank accuracy rank 2 is basically the guess that it was correctly recognizing the person upon the second guess, and the upon third guess it was also recognizing the correctly. This was the result of detection that I got on Fox. To have in the same wavelength as the NIST reported result, the data was first partitioned into the good, bad, and ugly images. For bad and ugly, they utilized the term of challenging and very challenging images. Each partition got approximately 3,000 images on average. NIST have provided the aesthetic classifier FRVT 2006 to partition the images into good, bad, and challenging and very challenging images. The paper description, the Fox dataset description is given in their own research paper. I have also provided the name here below. I have plotted the confusion matrix for each partition separately. These are the performance measure I have for this is the confusion matrix for the good partition, this was the for bad partition, and this is for the ugly partition, having 437 cross 437 matrix. Here is the two labels, and you can see the a very a diagonal having two positive and the upper and this is also the two positive representing in the and they have the support of about 3 images of each subject. These are the performance measure along with results. I have reported the result of on each partition separately so that I would able to match my result with benchmark that NIST has provided. So on good images I reported the equal error of 10.58, on bad I have 12.68, and ugly I have used the same class the softmax and Adam for parameter tuning, and learning wave was set to 0.005. The I have used also in that these were results that was reported on the Mobilenet while setting the alpha equal to alpha and beta setting to 0.75. These are the illustration of comparing the result with the benchmark. The NIST was able to get the good or results on good images than Mobilenets. As you can see, while Mobilenet for my methodology was better to behave in terms of feature extraction and identification on challenging series. One more gap which I have addressed, that I have fused all images and again ran my freeze model and got the accuracy of upon about 93%. This is the another illustration, and upon the LRPCA algorithm, local region principal component analysis they have used, and I compared with my Mobilenet methodology, and you can see the comparison of the results. Upon challenging and very challenging, my model was performing far better than the LRPCA. So these if you do not use the transfer learning techniques, you can use these steps as well, which I have written for future direction. That you must have to random cropping and scaling the image for data augmentation. First, color jittering, use principal component analysis data augmentation, use of faster RCNN for speeding up the training and testing, use of RPN region proposal network for automatic localization of periocular region, like I have used Mobilenets and SSD. You can switch that with this region proposal network. Down and up sampling for effective memory utilization. Fusion of localization score with classification score. This is the framework I have also made for future direction. If someone want to pursue his or her research work in this periocular region, I have provided the detailed map from which you can go from this clockwise, and then you can pursue your own research in this area by using how can you use the deep learning framework into this. The paper was submitted in the IAT Biometrics, impact factor having 1.836. Thank you. Any question? And thank you so much. If you like this, please subscribe my channel and share it. Thank you.